Hi, in this video we are going to learn about the concepts behind digital counters. On completion of this course, the learners can able to understand what is a counter and how the counters are used to count the given sequence. So basically counter is a digital circuit. So here synchronous counters and asynchronous counters are the classification of counters. So synchronous counters are categorized into various types, that is modulus counters, decade counter, up-down counter, ring counter and Johnson counter. So first one is the modulus counter. Modulus counter counts through the particular number of states. Then decade counter. Decade means modulus 10 counter, that is counts through 10 states, that is called as decade counter. Then up down counter, it counts both up direction and down direction and both up down direction, that is called as up down counter. Ring counter, that is formed by a circular shift register, it counts in a circular way, that is called as ring counter. The next counter is called as Johnson counter, it is called as twisted ring counter. Then gray code counter, here outputs a sequence of gray code, that is called as gray code counter. So basically counters are implemented in a variety of ways, that is indicated on MSA and LSA integrated circuits as embedded counters in ASCII, general purpose counter and timing purpose simply from microprocessor and microcontroller. This is the counter circuit which is used to count. Decade counter is the one which counts the decimal digits rather than the binary, that is called as decade counter. Decade counter may have each that can be varied from binary coded decimal. Here counter synchronous and asynchronous counter. Synchronous counter in the sense here the clock pulse given is at a time for all the flip flops, the clock pulse is given in case of synchronous counters. For asynchronous counters, one flip flop's output is given as the clock of second flip flop, that is called as asynchronous counter. So that the flip flop counter starts from 0 to 9 and then resets to 0. This counter output can be set to 0 by pulsing the reset lines. The count then increments on each clock until when it counter sets to 0. For 0 0 0 0 is the final state of the synchronous counter. So indicating that there is the counter starts its counting. So simply we can tell the counter will start counting from one sequence, and after making one complete count it will end to that sequence. Here according to the ICs used, the counters are classified. Counters are implemented in variety of ways. Synchronous, asynchronous, both are the mainly used types. According to the names, we can tell for synchronous counter the clock pulse is given at the same time. The output of one counter's output is given as a clock of second counter, then it is called as asynchronous counter. So for asynchronous counter, it should wait for the output of first flip flop, so that it will be taking some more time to perform its next operation. So the delay will be more in case of asynchronous counter. But in case of synchronous counter, the flip flops clock will be applied at the same time, similar time, so that it will be operated in a fast way, speed way. So speed way in the sense the flip flops output will be received at the same time, no need for waiting purpose here. So this is called as synchronous counter. So generally synchronous counter and asynchronous counter. For synchronous counter the operation speed is more. For asynchronous counter the speed is less. So delay will be taken. These all are the types of counters. It is used to count the given binary digits So the given binary sequences are counted according to the clock pulses given. So counters are mainly classified into analog ripple counter and Johnson counter, etc. So according to the clock pulses given, the triggering will also happen. Triggering is based upon edge triggering and level triggering. These all are the types of counters. So mainly counter is a circuit which is used to count the digital data. So in ordinary 4-state counter, it can be easily modified to a decade counter by adding a NAND gate as a systematic right portion. So in flip-flops, two flip-flops are connected and clock pulses are given. So it counts from 0 to 9 and pulsing the reset line is low. This all so decimal counter 0 to 9 one will be activated. So these are the types of counters, and counters are used in digital circuit for counting these sequences, and counter will stop counting when it reaches its initial position.